Hello, welcome to Notes 1.08. Today we're going to be looking at the equation of a line. So we're going to think y equals mx plus b. We're also going to have some slope and y-intercept. A few things I want to refresh our brain on is our x and y-axis, the origin, where your quadrants are, and so on. So remember, your x-axis goes left to right, or y-axis goes up and down. The origin is your ordered pair 0, 0. The quadrants start in the top right for quadrant 1, and they are numbered with Roman numerals. Then they go counterclockwise, quadrant 2, quadrant 3, and bottom right is quadrant 4. The line y equals 2 crosses your y-axis at 2. So if I were to draw that line, I'm just going to change colors here. At y equals 2, it's going to be a horizontal line up 2 from that x-axis. So it crisscrosses the y-axis. It makes a perpendicular with it. If I were to graph this line here, y equals a half x minus 3, and we practiced graphing some lines on our last notes to 1.05 when we did algebra throwback. But here our slope is 1/2 and our y-intercept is -3. So if we start at -3, rise 1, run 2, we have another point, up 1 to the right 2, we have a second point. Carefully connecting those, we have the line y equals a half x minus 3. Now the next line here, I'm going to graph in purple, is y equals -2x plus 1. Now remember that slope is down 2 to the right 1. We like to make that a fraction. So it crosses up at +1, and we go down 2 to the right 1, down 2 to the right 1, and repeated. We get this purple line here. There's something I want you to notice about the black line and the purple line is that they meet at right angles. So with those two slopes, we had y equals a half x and y equals -2/1x. Those two slopes are considered negative reciprocals. So these two lines are considered to be perpendicular. So when you take a fraction, you flip and negate it, that's called a negative reciprocal. Our slope formula, we haven't really looked at yet. I've been explaining it to you guys, remember, as the change in y over the change in x, or the rise over the run. But we need to remember it's y2 minus y little 1 over x little 2 minus x little 1. Okay? So that's just our slope formula. We use a little m for slope. And there's 3 ways to write the equation of a line. We like y equals mx plus b. That's really easy to help graph. We identify our slope and y-intercept. Standard form goes ax plus by equals c. We sometimes see questions written in standard form, and then we do our reverse operations to get y to stand alone. The last form that we saw a little bit of on Notes 1.05 was our point slope formula. Y subtract y1 equals m times x minus x1. And we're going to look at that a little bit more today. Okay. We've graphed some parallel lines already, so I want to just remind you that parallel lines always have the same slopes. They rise and run at the same rate. So if we had to write the equation of a line parallel to y equals -3x plus 10, we would start with y equals, and as long as it has a slope of -3x, we don't really care what the y-intercept. The y-intercept could be plus 85. As long as this slope of -3 and that slope -3 match, those two lines will rise and run at the same rate. So again, that y-intercept was kind of irrelevant, just a new line that wasn't crossing at +10 as well. perpendicular lines have negative reciprocal slopes. So that's the word have. Have negative reciprocal slopes. It's an R. Let me rewrite that. Sorry, guys. What that means is if we have this slope again of -3, what we do is we write that as a fraction, and then to change that to a slope that's perpendicular, we flip-flop the fraction, so it becomes 1/3, and we change it to a positive fraction. So if it is negative, it becomes positive. So looking back up here at the two lines we graphed, positive slope climbs your page right to left. Negative slope comes down your page. So 1/2 becomes -2/1. So write the equation of a line perpendicular to y equals -3x plus 10 would be y equals 1/3 x plus, and the y-intercept actually could be the same there, because if it crosses at the same point, that means that's going to be their point of intersection. But one would rise and run up to the right, the other one would come down your paper left to right. So looking here, what is the slope of each line? So I'm not going to just identify the slopes. I'm actually going to find the slope perpendicular as well. So let's look here at letter A. So let's practice solving each equation for y. The first question, to get y to stand alone, we would subtract 2 from both sides. So we have -y equals 3x plus 3. Then we have to divide by a -1. So remember, you've got to be careful when you're solving your equations. So here we get y equals -3x minus 3. So if our slope there is -3, the slope of a line perpendicular would be +1/3. And we just looked at that in the example above here. So again, negative slope flip-flops the fraction. Looking at exercise B. 2x equals 10 minus 5y. Now I'm going to reverse operations to get this y to stand alone. So we can subtract 10 from both sides. And we get 2x subtract 10 equals -5y. And we divide by a -5. So our final equation says -2/5. Now it doesn't matter where we put the negative for that first fraction. And -10 divided by a -5 would be +2. Oh, I forgot my little x in there. Sorry about that. Equals y. So seeing that my slope here is -2/5, my slope of a line perpendicular is going to be 5/2. So again, I'm just practicing finding that negative reciprocal slope. Exercise 3, again, we want to get y to stand alone, so we're going to add 3x to both sides. 2y equals 3x plus 12. I do like to keep the x term first, so as I rewrite this, I keep the 3x there. Divide through by a 2. Y equals 3/2x plus 6. Now to find our slope of a line perpendicular, we're going to take 3/2. Find its negative reciprocal is going to be -2/3. So again, if the slope is positive, we automatically make it negative. If it was negative, like example B, we made it positive. Now looking here at letter D, this equation is in point slope form. So I know point slope form reads y minus y1 equals mx minus x1. So if we were to pull out the point in the slope, and again, this was in notes 1.05, we're working more with this formula today, but that means our slope here is -3. It's that number right in front of the parentheses. And the point x1, y1 that this goes to, or that this line would go through, is going to be -1, comma, +5. So remember, from that equation, when we pull out the point, we flip-flop the signs. So in this case, our slope perpendicular from -3 would become +1/3. And we've looked at that slope a couple times already. So looking here, exercise 2 asks, are the lines parallel, perpendicular, or neither? Now, this is where your graphing calculator can come in handy. If you go to type in these two equations, 2x plus 7 and 2x minus 2, okay, and hit graph, your graph is going to graph those two lines for you. So 2x plus 7 and 2x plus 2, if you forget what they are, look at your picture. Those two lines are parallel. Okay. Letter B, y equals -5x plus 9 and y equals 1/5 x minus 3. So -5x plus 9 and 1/5. Now I'm just looking at those slopes. Those are negative reciprocals, so these should look perpendicular. And something I want to explain to you, so when you graph them in your calculator screen, this screen is more rectangular than it is square. So this might not look exactly perpendicular. So that's where knowing the rules is really important. But -5 and +1/5 are negative reciprocals. So these are going to be perpendicular. And remember, your symbol for perpendicular is that upside down T. Letter C is a little bit different. Here we have -1/6 and -6 are two slopes. Those are both negative. So in the graph, those are both going to come down your paper. So again, if I have -1/6 x plus 6, forgot the other 6 there. And just -6x minus 4. And I hit graph. Those two lines kind of come down your screen from left to right. They're not meeting at a right angle there. They're just going to intersect. Again, one of those slopes would have to be positive for them to be perpendicular. And for letter D, you don't know just looking at those two equations. So you do have to solve them. So if you want to pause the video, solve them on your own to decide. I'm going to do this quickly. Subtract 3x from both sides. 2y equals -3x plus 18. Divide through by 2. I'm not going to rewrite it because I just want to focus on getting that slope there, -3/2. And the second equation, we add 2x over. 3y equals 2x plus 33. Divide by a 3. And again, now focusing on that slope. Now this is an equal sign here. So -3/2 and +2/3, those lines would be perpendicular. Okay. So again, sometimes you have to solve your equations to decide if they're parallel or perpendicular. Point slope form reads y minus y1 equals m times x minus x1. That's the formula. And what we are going to be given for these equations is like example 3 here. They give you a slope and they give you an ordered pair. So the steps to be writing an equation. So we use point slope form when you're asked to write an equation. So when asked to write an equation, determine the slope in your in your ordered pair x1, y1, make your substitutions, and then we solve for y to get it into our y equals mx plus b form. Now, on a state exam, your first substitution here is a sufficient answer. It is the equation of a line, but we really do like to see it in this y equals format that we were solving for in letter D. So our formula reads y minus y1 equals m x minus x1. So I like to write the formula out first. And the question reads, write the equation of a line whose slope is 4, so that tells us our m value, and goes through the point x1 is 3, y1 is 2. So that's the first x value, the first y value. So making our substitutions, y minus our 2 is the y value, equals our slope 4 times x minus our x1 value is 3. So again, these positive numbers become negatives in that formula. And the last step we can do there is we can take that formula, y minus 2 equals 4 times x minus 3, and we can solve for y equals. So this is an okay way to leave it for a state exam question, but if you're trying to compare this equation to something else, we really would need to distribute. So y minus 2 equals 4x minus 12. Then we add our 2 over, and the equation would have a slope of 4 and a y-intercept of negative 10. So y equals 4x minus 10. Is that in point, point slope form? No point slope form. That's our equation written in slope intercept form. Those are the words I'm looking for. So this is our equation in slope / intercept form. But again, we started in point slope form. So reading exercise 4. Write the equation of a line that passes through the points 5, negative 10, and negative 2, 2. Now there's a question or two like these on your classwork today. So if I just scroll ahead to classwork, write the equation of a line that passes through two ordered pairs. So this process is a little bit different because if we go to use our point slope formula, y minus y1 equals mx minus x1, we don't have a slope. So the first step we need to do here is to find the slope, and that's where we're going to use y2 minus y1 over x2 minus x1. And I talked about that formula at the beginning of our equation. So if I make those substitutions, y2 is 2 minus negative 10 over x2 minus x1 is negative 2 minus 5. That gives us a slope of, well, this becomes 12 in the numerator over negative 7. 2 minus negative 10, negative 2 minus 5. Yep. Our slope there is 12 over negative 7. And that's an okay slope because we're just making a substitution, right? So that's the slope. So we needed to find that first. Now we can substitute. So making our substitutions, y minus my y1 value. So again, this was x1, y1 is negative 10. So y minus negative 10 equals our slope of 12 over negative 7 times x minus our x1 value, 5. Now that substitution's fine. I'm just going to make this nicer, y plus 10, and a lot of you were already adding the opposite. 12 over negative 7 times x minus 5. So we're just going to stop there. We've written the equation like it asked. So again, when you need to write an equation is really when I want you to use your point slope formula. So looking at the next question, number 5. Here we need to write the equation of a line. Write the equation of a line that passes through the point. So there's our x1, y1. for negative 5 and is parallel to this equation here. 3x plus y equals 12. So again, when we're asked to write the equation, we need the formula y minus y1 equals mx minus x1. So looking into our equation, right now we have the ordered pair x1, y1, but we need to find the slope. So given that equation here, 3x plus y equals 12, we're going to subtract our 3x over to find our slope. So y equals negative 3x plus 12. So our slope is going to be negative 3. And since we need an equation parallel to it, we're going to keep that slope. The next question changes a little bit. So looking here, we're going to make our substitutions. So y minus the y1, again, is negative 5, equals the slope, negative 3, times x minus 4. You guys might hear my kids in the background today. So we have y plus 5 equals negative 3 times x minus 4. That's going to be the equation of a line that is parallel to this 3x plus y equals 12. So if we think about it, if we were in the coordinate grid, we would So if we were to again graph this, we'd have a slope of negative 3x and it'd cross up at positive 12. So our line would kind of come in like this. And this equation, if we distribute our negative 3 and subtract over our 5, we'd have again a slope of negative 3 with a different y-intercept. So those two lines would be parallel. So the last example here for the notes is going to be exercise 6. For this question, it asks us to write the equation of a line. So again, we're going to use our point slope formula in slope-intercept form. So we're going to have to solve it this time. That goes through the ordered pair x1, y1, 10, comma, negative 2, and is perpendicular to 5x plus y equals 12. So for the first thing we need to do is find the slope, perpendicular. Because to go into our equation of a line, that y minus y1 equals mx minus x1, we have the x1, y1, but we need that slope. And in this case, we need the slope perpendicular that goes into here. So our 5x plus y equals 12. Subtract 5x from both sides. We get y equals negative 5x plus 12. Means that our slope right now is negative 5. Therefore, the slope perpendicular is positive 1/5. So that's what's going to go in here for our slope. So making our substitution, we get y minus, our y1 is negative 2, equals 1/5 times x minus x1, or 10. And lastly, it did ask us for slope-intercept form, so we're going to have y plus 2 equals, and I'm going to distribute, 1/5 x minus 2, because 1/5 times negative 10 over 1 is going to be negative 10/5, or negative 2. And the last step is to subtract this 2 from both sides so that we get y to stand alone. So y equals 1/5 x minus 4. So that's the equation of a line that in the coordinate plane. So let's think back to the whole question here, okay? So our first equation was this one. Y equals negative 5x plus 12. So if I sketch that red line, negative 5x plus 12, let me undo that because it should be a little steeper. Okay, so we're imagining that this crosses at positive 12. So that's the first line that we started with. But we wanted a new line that went through the ordered pair over 10 down 2. So we need a new line that goes over, if we go 10 over and down 2 boxes, let's say it's about there on our graph. We want a new line that goes through that point and is perpendicular to the line given. So my sketch is a little bit off, but we found this line here, y equals a fifth x minus 4, has positive slope, and it goes through that ordered pair and crosses the y-axis down 4. Okay, so that's how we write these equations. So again, when you're asked to write the equation of a line, you're going to need your point slope formula, y minus y1 equals mx minus x1. And again, in order to go into that point slope formula, you need the ordered pair, the point, and the slope. So I'd like you to try the classwork 1.08. Here, this first question, if two lines are perpendicular and the equation of one of the lines is y equals negative 4/3 x plus 2, what's the slope of the other line? So you're really just going to give me the slope perpendicular to this negative 4/3. Exercise 2 is asking the same question. So again, remember perpendicular is the negative reciprocal. Parallel is equal slopes. Exercises 4, 5, 6, and it should be 7. These next 4 examples are very similar to number 3 from the notes, number 4 from the notes, because in number 3 here, number 4 was going through the ordered pairs. So this is very similar to number 4 in the notes. I think I numbered those on purpose. This is very similar to number 5 from your notes, and so on. Number 6. And I might have just read that wrong a second time. Sorry, my kids are arguing upstairs. But either way, these correspond to notes questions. So you might want to have both pages kind of open for yourself. Remember, the length is the same as distance. Okay, and we did that in notes 1.07. Midpoint formula you need for letter B there. And then this is a Regents question. And lastly, question number 10. When you bisect an angle, you get 2 equal angles. So the measure of ABD equals the measure of angle CBD. So you're going to be setting x squared equal to 60 minus 7x. And you're going to have to solve a quadratic here. Okay, so good luck with this classwork. Please upload pictures when you're done. Thank you.